Welcome back to my classes. Today we will have a discussion about the biostatistics. So what is biostatistics? Biostatistics is nothing but it is the application of the mathematics to the science. So whatever research we are doing, it should be represented in a proper way. So how we are collecting the data, how we are representing it, how we are analyzing it, and after analyzing what is the interpretation you got. All this can be made by using this biostatistics. So in the upcoming slides, we will see some of the basic terms which are involved in this biostatistics. The important term we regularly use is a sample. So sample is nothing but a group or a minimum number that is taken from the population. What is this population? Population means the complete source or the complete measurement of people, whatever is involved, that is population. For example, what is the total people in the world or the India? We count each and every person, that is census. Census is nothing but taking or collecting the data from each and every person of the India, that is population. Whereas sample represents only few people are being taken into the study, that is sample. In simple terms, if you take how many students are present in a class today, so we count each and every student, so that gives population. Then come to the sample. If I, for example, a lecturer says call some 5 or 10 students from a class, so this 5 or 10 represents the sample. Hypothesis is nothing but assuming or guessing something is hypothesis. So hypothesis testing is an assumption that we make about the population parameter. For example, a person says daily I will take full of vegetables, fresh vegetables and fruits. So my immunity will be more. So that is an assumption. As he person is taking more vegetables and fruits, he is assuming that he may have more immunity. That is assumption. That is called as hypothesis. The two major types of statistics are descriptive statistics and inferential statistics. So descriptive statistics, as the name indicates, they are helping us to describe or summarize something about the population data, a set of population data. So here it is helping a researcher to report something on the population and the samples. For example, there are some 100 students in a class. We say there are 75 girl students and 25 boy students. So we will give a graph saying that 75 girls and 25 boys, that is describing a character. Among the 100% of students or 100 students, 75 are girls and 25 are boys. That is description about the sample. Whereas inferential statistics says like it is giving a generalized information. Like if you want to know the total number of girl students or boy students in the whole state, then we will take a sample from every college and we will give an overall idea. Like there may be some, like from every class or every college we are taking information and generalizing, there may be so many girl students and so many boy students. So the generalized data giving the information on whole population is inferential statistics. So descriptive statistics, we are doing an set of population data, whereas inferential statistics we are doing on a whole population and we are giving the inference, the generalizations about the population. Data is nothing but the collection of information, whereas the raw data is nothing but the information when you are collecting it from the original source, we call it as raw data. So variable is nothing but on what topic you are going to do the study. It may be human beings, it may be a place, it may be a thing, it may be any idea also. So on what you are doing the study, we consider it as variable. So this variable can change from one entity to the other end. Few people may do the study on the human population, few people may do the study on the industries, companies, how they are working on certain things, on certain ideas, on certain place. They take a certain place, what is the temperature in that particular area, they may do the research on that. So from entity to entity the variable may be changed, whereas a random variable is the one whose values are being determined by chance. It can be changed. For example, if you are flipping a coin, you may get heads or you may get tails. So, how many times you flip, there are so many chances of getting heads or tails. That is nothing but random variable. The value can be changed every time you inspect this. So, every time you flip a coin, there is a chance of getting heads or tails. That is random variable. So, any information on which you are going to do the study, if you are going to do the study on the human population or in a particular business like biscuits business, chocolates business, or if you are going to do a test on anything, that is a variable. So, all the information regarding that variable, we call it as a data. So, this data is of various types, which indicates quantitative data and qualitative data. So, as the name indicates, quantitative, what is the quantity of that particular data, and what is the quality of that data is qualitative data. So, quality is not numerical, so it is non numerical. Whereas quantitative data, it is two types, discrete and continuous. So, what is the difference between this discrete and continuous is discrete gives you a particular value, like 5, 6, the complete number. Whereas continuous means like 5.6, 2.6, it is continuous. So, in this continuous also, it is of two types, interval scale and rational scale. So, this interval scale, as the name indicates, it gives you a proper interval. Like the difference between two is like temperature between the 50 degrees and 60 degrees is 10. That is 10 is the interval. Whereas a rational scale, it gives you a specific number. There is no specific interval here. That is rational scale. For example, what is the age? Age will be 7, 8, 20. So there is no intervals. Height, weight, all this is a particular value. Whereas the temperature, it can be an interval. It may be some 50 to 60 degrees. What is the today's temperature? It may be some 40 degrees to 50 degrees, 20 degrees to 30 degrees, like that. Whereas a qualitative data is non-numerical, which indicates, this is again of two types, nominal and ordinal. Nominal indicates a specific name or something is nominal data. So whereas the ordinal indicates like what is the blood group of that particular patient, that is ordinal. Blood groups, what is the performance, yes, he is an average student, so average, good, that is ordinal. Nominal means, for example, in a when you are filling some form, it indicates sex, male or female, so that is nominal. What is your gender, what is your name, that is nominal. Whereas ordinal means, what is your blood group, what is your performance? Yes, he stands third in the class. You are average in the class. He is good in the class. That is ordinal. So the major statistical tests are of two types, parametric and non-parametric test. Parametric is a test which can be performed where the assumptions are possible. So this test can make assumptions about the population parameters and from where this data is coming, distributions that the data came from. This parametric test includes student t-test, ANOVA, where the data is having a normal distribution. Whereas a non-parametric test, it can't have any assumptions. So it is called as non-parametric. It doesn't have any assumptions about any population parameters. And the examples of this test are chi-square test, Fisher's test and Mann-Whitney test. So here are some differences between the parametric and non-parametric test. As we have seen, parametric tests have the assumptions about the population, non-parametric doesn't have any assumptions. Whereas parametric have a normal distribution probability, whereas distribution is arbitrary. Arbitrary is nothing but they can do however they want. There is no specific idea how they are going to distribute them. And parametric will use a mean as a central tendency. Mean is nothing but average. If there are two numbers, so we'll take the average of that. For example, 2 plus 4 by 2, that is the mean. Whereas median indicates the middle value. The non-parametric is using the median as a central tendency. For example, 1, 2, 3, 4, 5. Here 3 is a middle number. So 3 is the median. Whereas parametric requires the previous knowledge about the population, whereas non-parametric doesn't require any knowledge about the population. Bias, which plays a major role in our study. So bias refers to the tendency of a measurement process to over or underestimate the value of population parameter. So in this video I have kept the basic terms which will be helpful for the research study. I hope this will be useful for you. Thank you.